All right, welcome to this explainer. Today, we are tearing into a high-octane technical deployment roadmap pulled straight from the Prathamesh Thakur Master Archive. We're skipping the basic surface-level stuff. Instead, we're diving into an authoritative, intellectually sharp look at what it literally takes to build enterprise-grade software today. Think of this as a premium tech documentary deep dive, tracking a rigorous 4-week internship challenge centered entirely on AI-first software development. Our deployment roadmap for this 4-week sprint is structured strictly bottom-up. We'll start with the vector math foundation, move into algorithmic processing efficiency, build out our ecosystem architecture, and finally hit market execution.
Week 1, the AI Vector Mathematics Foundation. This is where we separate the casual consumers from the actual builders.
Let's get one thing straight right out of the gate. As engineers, we've got to move way beyond simple passive prompting. We absolutely have to drop this illusion that AI is somehow thinking. Under the guidance of instructor Akanksha Goswami-Mam, we're redefining large language models mathematically. They aren't conscious, they are specialized ML architectures that predict logical sequences using multi-dimensional numerical vectors. It's pure geometry.
It all boils down to this stark reality. Systems predict patterns mathematically. That is the foundational bedrock for any serious AI-first software builder. When you use tools like ChatGPT, Notebook LM, or Teachable Machine daily, your goal isn't just to use them, it's to observe those multi-dimensional vectors firing in real time and figure out how to deploy them practically.
Moving up the stack to Week 2, Algorithmic Processing Efficiency. Guided by Kutij Mishra Sir, we tackle the exact hardware and algorithmic optimizations that totally dictate your execution speed.
So at the micro level, your computer is just processing pure binary states, right? The simple presence or absence of voltage. A standard 1 GHz CPU is ripping through roughly a billion operations every single second, which sounds infinitely fast. But the reality? That raw CPU speed is incredibly susceptible to bottlenecks.
Because, look, that blazing speed means absolutely nothing if the way you arrange your data causes friction. The memory hierarchy dictates your read and write latency. Persistent storage on a hard disk is slow. Volatile RAM is much faster. And CPU caches and registers, those are near instantaneous. As an engineer, your core friction is how data arrangement inside that RAM governs access speeds. Arrays use contiguous memory blocks for super-fast indexing, while linked lists force you into slow, step-by-step pointer traversals.
To truly grasp this friction, let's look at a pretty devastating case study, searching for a connection on LinkedIn. Say you want to find a fourth-degree connection. If you use a naive breadth-first search of BFS array scan and factor in a totally realistic boundary of 5,000 connections per user, the computation scales exponentially. It scales so terribly, in fact, that it results in a catastrophic 72 days of processing. Seriously, imagine waiting 2.5 months just to find out if you know a guy who knows a guy at Google. It's completely broken.
And this is exactly where we pull the optimization lever. We have to rip out that naive, exponentially failing array scan and replace it with a hash-based structure, specifically a hash set.
By leveraging that hash set, just one single algorithmic shift collapses that nightmare 72-day bottleneck into a stunning 0.5-second execution. Half a second. You've instantly transformed an unusable platform into a seamless user experience.
The massive metric shift here is achieving an average O of 1 time complexity for membership checks. It transforms those brutal exponential lookups into near constant average time checks. This level of mathematical optimization, it's the razor's edge difference between a failing amateur project and a highly scalable enterprise-grade product.
Week 3, Client-Server Ecosystem Architecture. Under Aditya Akash Gupta Sir, we take these hyper-optimized algorithms and actually wire them into deployable web ecosystems.
Enterprise web stability is entirely governed by this continuous client-server architecture. It's a strict request-response cycle across the network. The front-end UI perfectly maps your user interactions, the network transmits those API endpoint requests, and the back-end manages the state and data persistence. That loop, that is literally the heartbeat of the internet.
I absolutely love this quote from the archive. As a builder, your days of being a passive consumer are over. You can't just mindlessly scroll anymore. You must actively audit every application's request-response cycle. When you fire up Spotify, you shouldn't just be hearing music, you should be visualizing the API endpoints fetching compressed audio from a back-end database and delivering it straight to a front-end UI map.
Finally, Week 4.
operational execution and market. We take our beautifully engineered stack and we launch it into the brutal reality of the market.
Here we draw heavily from instructor Lucky Soni Sir's operational realism. The hard truth is, enterprise value isn't built on cheap, non-exclusive ideas. It's built on ruthless consistency and integration. Think about Everon Nutrition utilizing NASA-grade freeze-drying. Or on the software front, deploying custom AI chatbots and automated logistics assignment engines to just completely slash your overhead. Ultimately, the only real validation is a customer's actual willingness to open their wallet and pay.
So, your execution mandate is incredibly straightforward. Fail fast, iterate rapidly. To even survive in today's landscape, founders have to wield AI tools as absolute power users. You need to constantly upskill, iterating your product cycles at blinding speeds to find out what the market truly values.
When you put it all together, this timeline brilliantly charts Prathamesh Thakur's own evolution. In just 4 months, we watch a Class 12 PCM student transform, from learning multidimensional vector math to architecting O-of-1 algorithms, all the way to deploying live, full-stack automated ecosystems. It is a masterclass in the strategic transition from a student into an active tech builder commanding the entire stack.
So as we wrap up this explainer, I want to leave you with a real challenge. Audit your own work right now. Whether it's a code base, a business process, or your entire operational pipeline. Where is the exponential scaling hiding in your systems? What high-latency, 72-day bottleneck can you completely eliminate today using this AI-first engineering blueprint? Figure that out, crush your limitations, and start building.